So last week we learned how to convert from logarithmic form to exponential form. And then Monday we learned how to identify the different properties and rules of logarithms to manipulate them. And we're going to continue on with those same basic principles in today's lesson. So the first example is log base 3x plus log base 3 4 equals log base 3 80. So let's go ahead and take a look at just the first part of this equation. Which rule can I use to condense those logarithms? How can I combine them, Brandon?
Log 3 plus, right.
You can look at the rules that we learned on Monday. The product rule. Good, George. What does the product rule tell me? If I'm adding the logarithms, how can I condense them or combine them? Multiply. Good. So what am I multiplying, George? I'm multiplying my x and my 4, right? So if these are being added, then I can multiply them. And then I'm still left with my right side here equals log base 380. Good. So now what rule can I use to solve for x? Natalie said it. Equality rule. What does the equality rule tell me, Natalie? Good. And the reason I can equal them to each other is because they have the same base. And when they have the same base, I can then conclude that these are equal to each other as well. So I could say 4x, I prefer to have my number in front, equals 80. Are we okay with that?
Yeah.
Can we solve for x? How do I solve for x?
You divide.
Divide by 4, and x equals 20. You guys are so smart. Perfect. Let's go ahead and take a look at number 2. I've got log base 8x minus log base 8 5. So the first thing I'm going to do actually is let's go ahead and take a look at just this highlighted portion right here and combine them. What's happening to these logarithms? They're being subtracted. So which rule am I going to use, Michelle? The quotient rule. Awesome. So the quotient rule tells me that I'm going to do what? She said log base 8, and then let's kind of show people where they're coming from. So we have x over 5. Perfect. And that's all equal to 1 still. Perfect. So how can I solve for x? What do I need to do next? Can I do the same thing I did on the last side, on the number 1?
Mm-hmm.
Why not?
Because there's a fraction and
Okay, it's not only because there's a fraction. Do you notice here that I had a log on both sides of my equation when I was done, right? And on this side, I don't have a log. So what can I do instead to solve for x? I can't just set x over 5 equal to 1, right? What does that mean? So I think what you're trying to say, Michelle, is to go from logarithmic form to exponential form. Good. So we're going to go from log form to exponential form so we can get that log, get rid of the log, right? So I have, we'll kind of go back to last week's lesson. I have my base is 8, Michelle said, and my exponent is 1. And that equals x over 5. 8 to the first power is 8. And I still have x over 5. How can I solve for x? Brooke said it. Multiply both sides by 5. The opposite of divided by 5 would be multiplied by 5. And x would equal What is it? 40?
40.
Awesome. 40. So in your notes, I think it's an important thing to highlight is for number 1, I want you to put log on both sides. And we're going to be kind of highlighting this in several examples. So maybe we can make a little acronym like LOBS, LOBS, for log on both sides, if it's not going to confuse you. And on the other side, we could put that we needed to put it in exponential form. So make like a little asterisk and write exponential form. Just to highlight the difference between the two and how we got to our answer. Just a heads up that we do have a quiz on Friday. There is no special review sheet that I'm going to hand you, okay? You guys need to make sure you're doing your homework and make sure you're asking questions and make sure that if there's any questions that you have from last week's lessons and this week's lessons that you're asking me. Okay? Can I move on? Can I erase this? So far, so good? Okay. Let's go ahead and take a look at number 3. I'll give you guys a minute to write it down. At number 3. First, I want you guys to focus on just the left side of the equation. And let's use the rules we learned yesterday to combine those. So which rule am I going to use to combine log base 7x minus log base 7, 3?
Quotient.
The quotient rule. Awesome. And the quotient rule tells me that I'm going to do what?
You're going to divide them.
Good. So I have log base 7 x, and I'm dividing them, Brandon, because I'm subtracting the logs, right?
Yeah.
Divided by 3 equals, and nothing changed on the right side so far. Okay. For what do I do from here? How can I
Set them
solve for
equal to
x?
each other.
Why do I set them equal to each other, Brandon?
So you can.
Because they have the same base. It's important that we understand that the only reason we can set them equal to each other is because they have the same base. If you had log base 7 x over 3 equals log base 6 x over 3, or 51, then we would have to do something different, okay? But in this case, we can set them equal to each other because they have the same base. So I have x over 3 equals 51, and x would equal, if I multiply both sides by 3, what do I get? 153? You guys are so smart. We are going to be dealing with some bigger numbers today, and I'm okay with you guys using a calculator, but I do prefer that you use a real calculator. So when we get to that point, if there's a number that you can't do on paper or in your head, feel free to grab a calculator. Let's go ahead and take a look at number 4. I have log base 4 x minus 5 minus log base 4 6. So again, let's go ahead and just focus on the left side of the equation first. What rule am I going to use to combine these? I heard it. The quotient rule, Benjamin. Thank you. So the quotient rule tells me that I'm going to do what? Divide. So right now it's being subtracted, and I'm going to go ahead and divide log base 4 x minus 5 divided by 6. And it just equals the same thing that it equaled before, 1. So I have not changed any values. I've just combined my logs so that I can solve. Miss Ashanti, how am I going to solve it from here? Perfect. I'm going to put it into exponential form, right? So I've got my bases, beautiful, and that is to what power? Good, to the first power, equals my x minus 5 over 6. Are we okay with that, guys? Perfect. So let's go ahead and do some inverse operations to solve for x. I've got 4 to the first power equals 4. Are we okay with that? Equals x minus 5 divided by 6. You can either multiply by 6 and then add 5, or we can cross multiply. And I'm going to cross multiply for fun. So 4 times 6 would give me 24 equals x minus 5. How do I get x by itself?
Subtract, or add the 5.
Add the 5 to both sides. And I am left with x equals 29. You guys are so smart. There you go. So again, you might make a note to yourself that I was able to, let me put this in a different color. We were able to solve number 3 because we had logs on both sides. So maybe put a little asterisk and put logs on both sides, or LOBS for logs on both sides. And for number 4, we had to convert it to exponential form. So maybe just make a note that, hey, I solved this because I put it in exponential form first. Can I erase these? Questions so far? Okay. Let's go ahead and take a look at number 5 and 6. I'll give you a minute to write those down. Let's go ahead and take a look at number 5 first. So again, I'm just going to focus on the left side of my equation, my log base 4 6 plus log base 4. And just to kind of eliminate any confusion, this is actually log base 4, negative 2x. So this is not minus 2x separate from the log. Okay. All right. So what rule am I going to use to combine the left side of the equation? What's that? Product rule. And just so you guys know, I'm not going to ask you on the quiz what is the product rule or anything like that, but I just want you, it's important that you know the relationship between the logarithms. Okay, so if you see that it's being added, I need you to know what to do if I ask you to condense it. Or if it's being multiplied, I need you to know what to do to expand it. Okay? So Ashanti said I'm going to use the product rule, which tells me that I have log base 4 log base 4 6. And what am I doing with these numbers? When it's being added, I'm going to be multiplying them. Perfect. So that's going to be times a negative 2x equals 3. So how am I going to solve for x after this step?
Multiply.
Multiply what, Brandon?
6 times negative.
Okay, so next step would be log base 4, and 6 times negative 2 would give me negative 12x equals 3. Good. And finally, what am I going to do next? Go to exponential form, right? I've got my base is 4. My exponent is, and that all equals negative 12x. Good. Negative 12x. 4 cubed is what? 64. I think we had that one on the warm-up. And in our speed quizzes, how do I solve for x? Divide by negative 12. And I am left with, I'm going to do this the long way because sometimes I have to think out loud. So if I don't know these off the top of my head, I would just start breaking them down by 2s as I see it. So I know that these both go into 2. 2 can go into both of these. So I would have 32 and negative 6 I could do it again. 32 divided by 2 would give me 16. Negative 6 divided by 2 would give me a negative 3. And I think that's as simplified as it's going to get. Okay. I guess I could put equals x. If you guys left your answer in this form, I would be fine with that. If you calculated it into a decimal, I would be fine with that, as long as they're both equal values. Questions so far? Okay, let's take a look at number 6. I'm going to erase part of my side here. So number 6, I've got log base 9 x plus 5 minus log base 9 5. So let's go ahead and combine those first. Which rule am I going to use to combine those with? The quotient rule. You guys are on it. The quotient rule tells me that I'm going to do what to those numbers? I'm going to divide them. It's being subtracted. So I've got log base 9 still. And I'm going to divide x plus 5, x plus 5 divided by 5 equals log base 9, 11. How can I solve for x? Equality rule, right? Perfect. So I have log base 9 and log base 9, which tells me that x plus 5 divided by 5 has to equal 11 as well. So I'm going to use the equality rule. Say x plus 5 divided by 5 equals 11. To get x by itself, what's the first thing I should do? Multiply both sides by 5. Okay, good. Those cancel out, and I'm left with x plus 5 equals 55. And then I need to minus 5, perfect. And I am left with x equals, you guys are so smart. Perfect. So on the left side, again, you might make a note to yourself that I went to exponential form because there was no logarithm on the right side of my equation. But number 6, I had logs on both sides. Questions so far? You guys ready to try a few on your own?
Yeah.
All right, kiddos, so this was the answers to the U-Try. Did you guys have any questions on the answers that we have up here on the board?
No.
That's a good question, Isis. So when you put it in exponential form, you know that you're doing that because you do not have a log on both sides. Okay, so if you have a log on both sides, like you do in number 10, then you can use the equality rule once you've combined these logarithms. But if you do not have a log on the right side, then you would convert to exponential form. Does that answer your question? Perfect. All right, we're going to go ahead and wrap this one up. Thank you very much.